We're now ready for our final concept here in section 8.1, the idea of the p-value, aka the probability value. So the p-value or probability value is simply the probability of getting that extreme of a result just by random chance. And the p-value can be thought of as the area outside of our test statistic. Okay, so let's go back to our first example with the price of bananas. Oh, wait, I got to do one more thing for you. And that is talk about our conclusion. We will reject H naught if the p-value, the probability value, is less than or equal to alpha, our level of significance. We will fail to reject H naught if the p-value is greater than alpha. Now notice that I'm using a capital P here because P stands for probability value, where remember on the binomial, little p stood for the population proportion, and big P is the probability value. So let's go ahead and look back at our example. So with the price of bananas, we had our critical value of negative 1.833, which gave us 5% of the area over here in the left tail. But our test statistic came out as t equals negative 1.12, I'm sorry, negative 1.19. And so we can see that the area outside or to the left of this test statistic has to be more than the area in the critical region of 5%. So if we were to take and find the area outside of the test statistic, not the critical value, but the test statistic, that is going to be what the p-value is worth. And we will see that it should be worth more than the 5% from the level of significance, alpha. To do this, let's remember that our degrees of freedom was 9, and this was a one-tailed test. So with 9 degrees of freedom on a one-tailed test and a test statistic of negative 1.19, well, we'll have to turn him positive, so he'd be positive 1.19, and that would put us between these two data values. So how much area would be in one tail on the t distribution with 9 degrees of freedom? Somewhere between 15 and 10%. Notice that these areas go down as we read to the right. So we'd normally say that it's between 10 and 15%. So let's go ahead and write that in on page 3. So our p-value, we don't know exactly what he is, but we know that he is somewhere between 10 and 15%. However, that is good enough narrowing down for me to know that the p-value is greater than my alpha of 0.05. Therefore, since my p-value is greater than alpha, I will fail to reject H naught, just like we did when we were doing the traditional way of drawing the picture, finding the test statistic, and seeing if he landed in the critical region or not. So this is another way to get to the conclusion, the same conclusion. So our conclusion will be fail to reject H naught, meaning we do not have enough evidence to conclude that the average price of bananas in all of central Utah is less than 62 cents per pound. Notice how we got the exact same conclusion in a slightly different way. We found the p-value and then compared the p-value to alpha, but in essence, that does the exact same thing as what we did before. If the p-value is greater than alpha, the only way that could happen is if our test statistic landed outside of the critical region. Okay? And the only way that we can reject H0 using the p-value is if the p-value is less than, but that will only happen if the test statistic lands inside of the critical region. Let's go ahead and do the next one together. Okay. On the second problem, or example 2 problem, where we had the home field advantage, remember that we used the z distribution instead of the t distribution, and it was a right-tailed test. Good thing we wrote that down. And our test statistic was 1.82. So if we wanted to find the p-value, we would take and find the area outside, away from the middle of the test statistic, not the critical value, and find out what that is. So in this case, we want to find the area to the right of z equals 1.82. So we'll pull out our z table, and 1.82 is 0.9656, but we'll remember that that is the area to the left. So our p-value then for this problem would be 1 minus 0.9656, which would be 0.0344. And notice that that p-value of 0.0344 is less than our alpha of 0.05. And if our p-value is less than alpha, we will, less than or equal to alpha, we will reject H0. So we will reject H0. And therefore conclude that there is enough evidence to conclude that the home team wins more than 50% of games. Okay. Now, again, this doesn't prove that the home team wins more than 50% of the games, because to prove you'd have to have 100% of the data, 100% of all the evidence, but we don't have that. That's what statistics is all built on, because we don't want to take the time to ask everybody. Now, we believe that it is more than 50% of the games that the home team will win. It might be 51, it might be 53, it might be 55. We don't know. We could narrow it down a little bit more by doing a confidence interval, by taking a large sample from a variety of sports, and then doing a confidence interval like we learned in chapters. But for right now, this is what we can conclude. All right, our last problem that we'll do to solve by the p-value method is to take a look at our two-tailed test with the final exam score data. Now here, on our two-tailed test, the area outside of the test statistic, since he's got two tails, I'd actually have to do outside of negative 2.24 and outside of positive 2.24. But what's most commonly done is we find this area in one tail and then just double him because he's a two-tailed test. Now, remember that this guy was a t-distribution with 35 degrees of freedom, and our test statistic is plus and minus 2.24. So let's look at our t-distribution, 35 degrees of freedom, and 2.24 would put us between these two data values, which means that the area in two tails is somewhere between 2% and 5%. Again, if we use the table, we don't get the exact p-value, but we get a neighborhood for where he is, and that will be good enough for us to make our conclusion. So our p-value for the final is greater than 2%, 0.02, but less than 5%, 0.05. And if we compare that p-value of somewhere between 2 and 5% against our alpha value of 0.05, we see that our p-value is less than alpha, so we will reject H star. Some people like a little mnemonic, and the mnemonic for this is if the p is low, meaning less than alpha, then no must go, so we will reject H star. And once again, give our real world conclusion. Since our alternate hypothesis was that the average score is not 70, that's our guilty verdict. We're going to go with that, put it into words. We have enough evidence to conclude that the average final exam score is different from 70. Okay. I hope that's made sense. In our next video, we'll talk about section 8.2, and we'll track through a few problems of hypothesis testing with the population proportion. See you next video.